We can use a very similar methodology to determine the power losses and the thermal behavior of the converter. You may have noticed when I run my script, the second plot pop up. In this plot, I'm showing the average power losses of the MOSFET in watt over the different operating region I simulated with my parallel simulation, and the average power losses of my diode. We can see that the MOSFET is losing a bit more, with almost 16 watt by high voltage and high current. The diode is a bit more difficult. We can see that actually the power losses are very much dependent on the current and not so much of the voltage. We can reuse these tables in software in a specific model built up for thermal simulation. You can see here I feed my voltage and current as a desired operating region. I'm recalculating the power losses using a lookup table, and I'm feeding them in a physical network which replicates my passive cooling system. My heat flow, the watt generated by the MOSFET. I have some thermal masses due to the mass of the junction. I have a connection to the case as well as some thermal mass, which has a connection to the heatsink. My passive heatsink then has a air convection with the ambient temperature. There is no active cooling. This is simply a passive system based on the ambient temperature. I can quickly change my operating region, like around 18 volt and 1 ampere, and then I can simulate for up to an entire day. You can see 2600 seconds for 24 hours. I can run. The simulation will be instantaneous. This is a very simple model, but this can be incredibly powerful technique for the engineers which are creating or assessing or sizing the cooling system for your power converter. We can see here that at our expected operating region, we actually are going to be around 318 voltages for the MOSFET and 318 Kelvin of temperature for the MOSFET and 328 Kelvin for the diode, which is acceptable. It's more or less 47 degrees. So of course it's the entire day with a lot of current, but it doesn't heat up too much. So we may be fine with a passive cooling system. I used a new probe block to get the temperature. You can use it for any kind of physical system. You double click, you pick a block, and then you will get access to all the variables that are inserted in this block. So this is a very convenient technique that allow you to build up a network and avoiding to instrument everything with sensor. This has been introduced in release 2028. Now, of course, if the passive cooling is not enough, your colleagues, which are working on the cooling system, may need to search for a fan to start blowing air actively on the heatsink. Maybe you need some heat exchanger as well. So we provide a lot of these blocks that allow uh, your team to work truly on the entire engineering aspect, not only on the power electronics, but on the cooling, sizing the cooling, and the cooling control. So this is what we think when we say that we provide truly a multi-domain simulation environment for a multidisciplinary team to work on. So as a recap, we saw how you can use the function getPowerLossSummary to create your table of power losses from MOSFET and diode. You can create a very fast implementation of your cooling system using simply the power losses at different operating point. We have an example for this called switching power supply thermal if you want to take a look at it. And we actually have a new function as well to hide this fidelity of your switching devices. We add the MOSFET and we parameterize the MOSFET based on the data sheet. But more and more, you can import existing model that you may have in SPICE directly into Simscape using the function subcircuit to SSC. This will, from a netlist, will automatically create a some Simscape component based on the SPICE netlist. We push this that right now we introduced SPICE models for our switches such as the SPICE imported MOSFET, and we provide some selection off the shelf for certain type of MOSFET, such as the one from Infineon. This is a repeatable workflow for you as well. So we provided conversion assistance. And of course, then you can validate this conversion by generating the characteristics and comparing with LT Spice.